So what the lesson yesterday boiled down to with an introduction to polynomial functions is, I guess, two things. Can you recognize a polynomial function? And a polynomial function basically consists of polynomial terms. And what a polynomial term is a coefficient multiplied by the variable raised to an exponent. And each coefficient, when you add all the terms together to get a string of terms called the polynomial, each coefficient has to be a real number, and each exponent on the variable has to be a natural number. In other words, exponents can be 0, 1, 2, 3, etc. Coefficients have to be real numbers, and the only non-real numbers really that we encounter or that I can use for an illustration are square roots of negative numbers. So as long as you don't see square roots of negative numbers, you're fine. The other branch of what we were talking about yesterday is how all of the numbers in the polynomial function tell you information about the graph. And we basically focused on two things. What's called the end behavior, and that means what does the graph look like on the left-hand end and on the right-hand end. And one of the things we learned is that if the degree of the polynomial function is odd, like this one, because the degree is 5, the two arms point in opposite directions. So one arm will be going up, one arm will be going down. Whereas if the two arms are in the same direction, that tells you that the degree must be even. So in question 2c, the two arms are in the same direction, and in 2e, the two arms are in opposite directions. The other thing related to the end behavior of the polynomial function's graph is the leading coefficient. If the leading coefficient is negative, then the right-hand arm, your right-hand side, is pointing down. And if the leading coefficient is positive, the right-hand arm is pointing up. So you put those two together, and if we focus on 2e here, since the degree is odd, it's a degree 5, 5 is an odd number, the two arms are in opposite directions. Since the leading coefficient in 2e is negative, the right arm is down, but if they're in opposite directions, the right arm is down, that means the left arm has to be up. We also talked about a few other things, like the fact that the constant term of a polynomial function will always be the y-intercept, and the number of x-intercepts is related to the degree of the polynomial function. The number of x-intercepts can be as large as the degree. So if the degree is 5, it can have 5 x-intercepts. If the degree is 6, it can have 6 x-intercepts. But it can have fewer x-intercepts, and it can have as few as 1 if the degree is odd. What does that mean? It means for e, and you can't tell by looking at this. Ian, you and I talked a little bit about this after the class was over yesterday. You can't tell by looking at e how many x-intercepts there are. But what you can tell me is there might be 5 or 4 or 3 or 2 or 1, but there has to be at least 1 because it's odd. Whereas in 2c, it's an even polynomial function, which means both arms are up, so there's a possibility that it doesn't have an x-intercept. It could be 4 x-intercepts in C, or 3 or 2 or 1 or none. Over the course of the next week or so, we'll be learning how to determine precisely how many x-intercepts there are, but we haven't gotten there yet. I think that pretty much covers what we talked about yesterday. Does anybody have any questions from any of the practice problems you'd like me to help you with? Ian?
On the practice number 1A, the book said that number A, or letter A, is not a polynomial function.
That's correct.
Why?
Because the exponent on x is not a natural number. The square root of x, written as an exponent, I'm just going to use y as opposed to h of x. We have 2, which is a polynomial term because it can be written as a real number times the variable raised to a natural number, minus root x can be written as 1, well, it's minus 1, but it doesn't matter. And a square root translates as an exponent to an exponent of 1/2. 1/2 is not a natural number. Any other questions? All right, so we're going to move on today and look at something called the remainder theorem. This is the next lesson in your handout. The remainder theorem, there's a content in the remainder theorem here today that's important for solving specific math problems that you will encounter. But tomorrow when we look at the factor theorem, the remainder theorem is going to be integral in understanding the factor theorem. Okay. We're going to be doing some division today of polynomials. Not division of numbers, division of polynomials. And one of the things I'm going to teach you is how to use long division to divide polynomials. And by the way, all of the polynomials we will be dividing today will be divided by a binomial of the form x minus a. That letter a, which is a parameter, is clearly not the same thing as the a in Unit 1. The a in this has nothing to do with vertical stretches. I hope that's obvious, but in case it isn't, I'm going to tell you that. So what we are doing today is we are dividing polynomials by a binomial of this form. This is what we're doing. So, I mean, I can show you quickly an illustration here of what I'm talking about. We'll get to the specifics of the lesson in a second. But for example, this polynomial 2x cubed minus 4x squared plus 3x minus 6 is going to be divided by x minus 1. So it's a polynomial, and we're dividing by a binomial. Okay. Incidentally, just because I say the binomial we are dividing by is of the form x minus a, doesn't mean that it's always x minus a number. It could be x plus a number. I could be dividing by x plus 2. And if I'm dividing by x plus 2, all that means is a is equal to negative 2. That's it. So we're doing this division using long division and something called synthetic division. So I need to discuss this with you because long division is very complicated. Okay? And I will tell you right now that you will be learning something as I teach you the long division that will be helpful. But unless you're going to go on and take a math course beyond this course, like calculus, you do not need to know how to do long division. So if I want to divide a polynomial by this binomial, I can either use long division or I can use synthetic division. Synthetic division is what we are going to be using in this course. I'm teaching you long division, one, because you need to know it for calculus, and I have students in here right now who are in calculus, and I also have students in here who I know may take calculus in the future. Okay? But if your brain starts getting backed up and bogged down with long division and you have no intention of taking math beyond this course, don't worry about it. Okay? And then we're going to connect the results of our division to what's called the remainder theorem. And it turns out there's a relationship between the remainder when you do the division and the value of the polynomial at x equals a. And we'll detail that in a bit. So I need you to focus up here, please, and not get ahead of yourself. You may think you know exactly what is required of you, but if that were the case, I wouldn't be necessary right now. You could just say do it yourself. So we're going to start by dividing 2,466 by 7. Now, you could just confirm on your calculator, actually, that if you take 2466 divided by 7, you're going to get a decimal answer. You're going to get something that has a decimal. And what that means, and I'm going to back way up to like elementary, junior high school here in this explanation. What that means is that if you get a decimal, not a whole number, it means that 7 is not a factor of 2466. This is really important. That if you divide one quantity into another and you have something left over, which we call a remainder, that means the thing you were dividing in is not a factor. So we're going to have a remainder when we do this division. On the other hand, and this isn't part of the question, but can you take your calculator and take 2466 divided by 3? Well, I believe you're going to get 822, if my thinking is right. And 822 is exactly 822, which means 2466 is 3 times 822. Think about that. 2466, since there's no remainder, is 3 times 822. Well, I've been trying to teach my students at every stage that a factor is something that's in brackets being multiplied. So 3 is a factor. That's why you don't get a remainder. On the other hand, I don't know what this was. 24, I would have to really challenge myself this morning, so I don't feel like doing that. I'll just do this on my calculator. You got 352 point something, right? So you had a remainder because there's that extra decimal. By the way, that decimal is not the remainder. Just to drive this home, because things are going to get quite complicated when we take a step from numbers to polynomials in a bit. If I say what is 20 divided by 3, I think you understand that 20 doesn't divide nicely by 3. Sometimes people will say evenly by 3, but I don't particularly care for the word evenly. I have 20 dots here. You can trust me. You could count them if you want. But if I wanted to teach a grade 2 student how to divide 20 by 3, I'd probably give them 20 Smarties and ask them to pile them in groups of 3. And this would be too much for their little tiny brains, because when they did that, if I asked them for an answer, they would have, 1, 2, 3, 4, 5, 6 groups of 3, but they have that left over, right? That leftover, that number 2, is what we call the remainder. And I know that you're probably looking at this and going, well, this is really elementary. I know it is, but it's going to get more complicated. If I say, what is 18 divided by 3? Well, I pile these 18 Smarties this time into groups of 3, and you can see that there is nothing left over. So again, what does that mean? It means 3 is a factor of 18 because there's no remainder. But 3 is not a factor of 20 because there is a remainder. So now let's get to this long division. And of course, you all remember how to do long division, right? No. No, you don't, right? It's a lost art. But we're going to need to know how to do this. So the first thing you do, there's a series of steps. And I think of it as layers. Each layer has basically 3 steps. And the first step in the layer is to divide this into a number. So you start off by saying, what is 7 divided into 2? And that doesn't compute. You cannot divide 7 into 2. So you extend that a bit and you say, well, what is 7 divided into 24? And you should be able to do that without a calculator. 7 goes into 24 3 times. Doesn't go 4 times because that would be 28. And you put the result up top. So this is step 1. The next step is to take what you got when you divided and multiply by what you were dividing in. By the way, this is called the divisor. And this is called the dividend. We don't worry too much about the dividend and knowing the name of it being the dividend, but the word divisor is important here. So we multiply what we got, which is 3, times the divisor, and we write the result below what we were dividing into. This is step 2 of the first layer. And the third step is to subtract the result from what's above. So 24 minus 21 is 3. I want to point out to you, though, excuse me, that when you divided 3 into 24, you were not actually dividing 3 into 24. You were dividing 3 into 2400 because of the placement of those two digits. And when you got 3, you didn't get 3, you got 300. And that's why it's written in the 100 columns. Don't forget, there's more zeros here, right? So when we subtract the 24 minus the 21, what we're actually really doing is taking 2466, subtracting 2400. Don't write the zeros in. That's not important. Okay, so we divide it in, that's the first step. We multiply, that's the second step. You subtract. I guess there's one more little thing you need to do, and it's to move the next number down. So what I would say to you is you repeat the process. And you would say, well, how many times does 7 go into 3? And you can't do it. So just like when we couldn't divide 7 into the 2, we looked at the next number added to it, written beside it. We do the same thing here. So we bring the 6 down. And then we say, how many times does 7 divide into 36? Let's see, 7 times 4 is 28. 7 times 5 is 35, so it's 5. So we put 5 up top. We're already into the second layer. We multiply. 7 times 5 is 35. We subtract and get 1. And you bring down the next digit in preparation for the next layer. So it's divide, multiply, subtract. Divide, multiply, subtract. Divide. You continue to do this. So can I divide 7 into 16? By the way, if you're at this stage and you can still divide 7 into the number you've written at the bottom, then you've messed up someplace. You put too small of a number up top. You put 4 instead of 5. Anyway, we bring that, I think it's a 6, down. 7 into 16 goes twice. We go 2 times 7, which is 14, and this is giving us 2. The end result here is you can no longer divide. You cannot divide 7 into 2. It doesn't fit. We're thinking whole numbers here. And there's nothing else to bring down, so we're done. Now we need to label some things here. This is terminology that you need to know. This is called the quotient. As I said before, this is the divisor. I don't really care too much about you knowing this, but the thing you're dividing into is called the dividend. And what you're left over with is the remainder. So we've labeled those terms. You do remember vaguely in your past doing this in some math class. I don't know. It might have been elementary school. Probably. Write the relationship between all of these quantities in two ways. Well, I'm going to go back to this. And we're going to talk about the one that's at the top. The 20 divided by 3. If I had 20 divided by 3, and I'm doing this, everybody, because some of you will forget the relationship between everything, and you might need to rebuild it by looking at something like 20 divided by 3, or 15 divided by 2, or something with a remainder. We have 20, which is the dividend. We're dividing by 3, which is the divisor. And we got for a quotient the result of the division. Let's see, we got 1, 2, 3, 4, 5, 6. So we got a quotient of 6. And then the remainder, of course, is 2. So what's the relationship between these two numbers, or these four numbers rather? Well, what does remainder mean? It means left over. But if you think that we can write 20 over 3 equals 6 plus 2, that's not right, is it? You know, this is what, I hate the word remainder because people would think it's something that needs to be added on. It gives you a quotient plus the remainder. No, that's not right because this is 8. 20 doesn't divide by 3 8 times. What you get is this. You get 6 plus 2 over 3, plus 2/3. Because you're left with 2 and you were dividing by 3, so you're left with only 2 out of a group of 3. You're not left with a whole group of 3. So the rule is going to be that the dividend divided by the divisor is always going to give you the quotient plus the remainder divided by the divisor. And the only reason why I'm not abbreviating the words dividend and divisor is they both begin with D. Okay. We could try to make this a little more general at this point in time by recognizing that this, in what we're going to be doing, is going to be a polynomial. We're always going to be dividing a polynomial by something, which is why I said to you, I don't really care about the word dividend. It's not that important. So, write the relationship between all of these things in two ways. Well, we could say, help me out here, was it 2466 over 7? Thank you. 2466 over 7 is going to equal the quotient of 352 plus the remainder of 2 over the divisor. Now just take your calculator and take 352 plus 2 over 7, and then take your calculator and calculate 2466 over 7 just to convince yourself that it's a true statement. The other way to look at it, and I like this better, going back to this makes more sense to me. We have 1, 2, 3, 4, 5, 6 groups of 3, plus we have 2 left over. This equals what we were dividing by. To me, that just makes so much more sense. This is saying the dividend equals the quotient times the divisor plus the remainder. In fact, if you take this statement here and multiply both sides of this equation by the divisor times the dividend over the divisor will be the dividend, the thing you're dividing by. Then you'll have the quotient times the divisor, and the divisor times the remainder over the divisor is just the remainder. That makes more sense to me. And by the way, if you can come up with this, then you can divide everything by the divisor to come up with the other way to write things. So another way to write this result in this question is to say that 2466 has to be equal to the quotient times the divisor plus the remainder. And you can convince yourself of that, by the way, if you take 352 times 7 and add 2, see what you get on your calculator. So this relationship that we're talking about here, whether you're saying dividend over divisor equals quotient plus remainder over divisor, which you've probably written down somewhere already, or whether you say dividend equals quotient times divisor plus remainder, this is called the division algorithm or the division rule, and we need to know it not only for numbers but for algebra as well, which is what we're doing at this level. So example 2, look at what we have to divide. We have to divide that cubic polynomial function 2x cubed minus 4x squared plus 3x minus 6 by x minus 1. I hope you see that fits the pattern of where we started today by me saying we're dividing by x minus a. The divisor here is a polynomial that's a binomial of that form. So this is going to be a little bit different. And remember, again, this is long division. So unless you have intentions of going on and taking math beyond this course, it's really not that important. But I still want you to follow along and do it. When you do your division, this is the weird thing about long division with polynomials. You have to divide, multiply, and subtract. Divide, multiply, and subtract. Same 3 steps in each layer. But when you do your division, you are only ever going to be dividing by looking at these. You're not going to refer to the constant term. You're simply going to say, what do I get when I divide? So this is step 1 of the first layer. We're saying, what is 2x cubed over x? And we don't say how many times does x fit into 2x cubed, because that doesn't really make sense. It makes sense with numbers, but not with variables. So I can see that when I take 2x cubed divided by x, I can cancel an x on the top and the bottom and be left with 2x squared. So 2x squared is the result of the division. I need to write it up top. And I need to write it in the same column as the other x squareds. This is where it's a little bit different than working with numbers. Then I'm going to multiply. But when I multiply, I'm going to multiply the whole thing. Let me be very clear here. When I multiply, I'm going to multiply what I got by the entire thing. I don't ignore the 1 at this stage. So I take x times 2x squared. 2x squared times x gives 2x cubed. Well, it better give 2x cubed because that's what we were dividing the x into. And then 2x squared times negative 1 is negative 2x squared. So that's the second step. When we get to synthetic division, it's going to be so slick and quick, it'll be unbelievable. So don't get too bogged down in this. Now what I'm going to do is subtract what I got from what's above. But since we're subtracting 2 terms, you need to subtract them entirely, meaning put them all in brackets. And then my reasoning, and I'm only using an arrow as a pointer here for anybody that needs to watch this on video because they're absent. I'm going to take now 2x cubed minus 2x cubed. Well, that's nothing. I don't need to write that down. Then I'm going to move over and I'm going to take a look at negative 4x squared minus negative 2x squared. Well, negative 4 minus negative 2 is negative 2. This is where you subtract the negative, you change it to positive. Negative 4 plus 2 is negative 2. So I get negative 2x squared. And I'm pretty much done that first, as I call it, layer of work, except to prepare for the second layer, I need to bring down the next term. You might recognize at some point that you don't need to bring it down now, but later on you'll have to do the subtraction. And I repeat, now I'm saying, so this was the first layer, now I'm into the second layer, I'm saying, what is negative 2x squared divided by x? So the things I am dividing now are these. And I don't worry about the 1 when I do the division. Well, this is equal to negative 2x. And I write that as a quotient above. Quotient is the result of division. And I write it in the x column. Now I multiply. And again, I'm multiplying the result of the division, which is negative 2x, I'm multiplying by the entire x minus 1. When I divide, I only use the x. When I multiply, I use the whole thing. So negative 2x times x is negative 2x squared. Well, it better be negative 2x squared. That was the point of dividing, to get the thing that would give us negative 2x squared by multiplication. Negative 2x times negative 1 is positive 2x. And you subtract. Now, I don't know if you recall, but I mentioned earlier that you didn't have to bring the 3x down right away, but sooner or later you would say, well, I have to. And this is the point where if you didn't bring this 3x down, you would go, well, I need to subtract. Oh, right. I got to bring this 3x down because I need something to subtract the 2x from. Negative 2x squared minus negative 2x squared is 0. 3x minus 2x is x. And I bring down the next item. And then I'm in my division stage of my what's going to be my last layer of work here. I'm going to be dividing this x that I'm underlining by the x that's highlighted in blue up top. So I don't think I'm going to write what is x divided by x. We know that's 1. You get 1 as a quotient, which you write in this column. And now you're going to multiply what you got by the entire x minus 1. 1 times x is x. 1 times negative 1 is negative 1. And you have to subtract. So finally, x minus x is 0. Negative 6 minus negative 1 is negative 5. And we're done the division. So when you divide that polynomial by x minus 1, you get a quotient of 2x squared minus 2x plus 1. This top thing is the quotient. This, of course, is the divisor. And this is the remainder. The dividend is what we're dividing by, but let's just call it the polynomial. Because if you take a look at what we're asked to do, we are asked to express our answer in this form. So the polynomial over the divisor gives us a quotient of 2x squared minus 2x plus 1 plus the remainder of negative 5 over x minus 1. That's very close to what I've written. It's in the same vicinity physically as what I've written there. So I don't want you to visually blend the two things together. This is the result. And, you know, I've got plus negative 5 over x minus 1. You'd probably just write minus 5 over x minus 1. I'm not going to worry about if you have questions about that, because as I said, this is for the Math 31 students and for calculus students, okay? Let's use synthetic division. And by the way, when we get to the stage that we're done, we're not going to do this again because we've already done that, right? It's in case you're missing the point, this is the exact same division. Are you with me on that? Okay. So what does synthetic division look like? Synthetic division is a big cheat. It's a way to cheat the system and get the answer. And you set it up by drawing kind of a box. You're going to want a box that's long enough to put all of the coefficients of the polynomial in and deep enough to have 2 layers of writing. And what we put along the top are the coefficients of all of the terms of the polynomial. And we leave a second space there because we're going to be putting other numbers. And let's not worry about right now why this works. If you're really curious, I can have a discussion with you on why it works. But the thing we're going to put to the left of this box is the zero of the binomial, is the number that makes this binomial equal to 0. So what number makes that equal to 0? Well, 1. And I want you to note that if we're comparing x minus a to x minus 1, the thing we're putting here is a. You're putting a there. A is the 0 of the binomial. And you do one more thing before you get started, which is to bring the first coefficient down below the line. Now, I'm going to warn you right now that if you go to your textbook puts -1 here. And they do it differently, okay? I don't want you doing it that way. The way they're doing it is more confusing, okay? But unless you know that, you might be doing some of this work together in class, and then you try to look at some examples in the textbook, and you go, what's going on? They do it differently. So now what you do, it's still layers. You multiply a by the number below the line and write that result in the next available opening above the line. Then you add these numbers. Not that it's really important, but does anybody have an idea of why we're adding and not subtracting? I mean, I know you don't understand why this is going to work, but why do you suppose I can get away with adding when I'm supposed to be subtracting something? Ian? Right. We're not using -1. We're using +1. So we've changed this number by multiplying it by negative from what the textbook would do, and then we can get away with adding. What your textbook does is it has a -1, and then it has to subtract each time. But would you agree subtraction's more confusing on the brain sometimes than addition? Okay. So we add these numbers, and we get -2. And then I repeat the process. I take a, which is 1, times the number below the line and write the result above the line and add the two numbers, and I keep going. 1 times 1 is 1, and I add -6 and 1, and I get -5. And these four numbers on the bottom of the line should look familiar to you, because our quotient was 2x cubed, no it wasn't, was 2x squared minus 2x plus 1, and our remainder was this. Boom, you're done. The thing you need to remember, though, is that when we started, this represented x cubed. So the numbers above the line represent the original degree of all of the terms, but as soon as you go to the answer below, it's 1 degree less. All right, so what are we going to learn from this? And you'll get lots of practice with synthetic division. One thing you learn is you sure don't have to do long division. But there's something more important here. Write a mathematical statement that could be used to check your division. I'm not going to write this out. I'm just going to say that the polynomial should be equal to the quotient times the divisor plus the remainder. Just like when we divided 20 by 3, 20 was equal to 6 times 3 plus 2. We're not going to spend time writing that out. Okay, in the next example, we're going to understand the relationship between the remainder and the divisor. There's a really cool relationship here. So we're going to divide 2x to the 4 minus 4x squared plus 7x minus 2 by x minus 2, and we can do it like rapid fire quickly using synthetic division. But don't write anything down just yet, please. Just look up here and tell me what would be wrong with me doing the following. What's wrong? Now, you might not know. I haven't taught you this yet. I'm just curious to see if somebody can figure out what I've done wrong here. I've told you to put the coefficients of the terms up top. I've told you to put the 0 to the left. And I've told you to bring the first coefficient down. If I told you that I wanted you to divide that by 3, would you do this? You wouldn't do that, right? So you would have to, even though there's no hundreds there, you have to specify that there are no hundreds there. When you take a look at this, there's no x cubeds. Well, then we better put a column for the x cubes and call it 0x cubed. So what you do need to record on your note package is 0 for the x cubed, 2x to the 4, 0 for the x cubed, negative 4 for the x squared, 7 for the x to the 1, and negative 2 for the x to the 0, or for the constant term. I don't know if I've talked about autopilot in this class. I know I have in my calculus class. When you do stuff like this, your brain shifts into autopilot mode, which means sometimes you're just writing stuff down without really thinking. Just be careful. So 2 times 2 gives me 4, and I add that to 0 and get 4. 2 times 4 gives me 8, and I add that to negative 4, and it gives me 4. 2 times 4 gives me 8, and I add that to 7, which gives me 15. 2 times 15 is 30, and I add that to negative 2 to get 28. I'm going to double check that, including to make sure I've written everything down correctly from the beginning. But it looks fine to me. Okay. So the remainder, the answer to the question is the remainder is 28. Now, part B says the divisor is x minus 2. When you compare these two, what is the value of A? Well, it's 2, right? We've already talked about this. Let's now, and I understand there's no C. Those arrows are for me to be reminded to fix my note package. Let's find f of A. Well, if A is 2, you have to find f of 2. That's 2 times 2 to the 4 minus 4 times 2 squared plus 7 times 2 minus 2. And I would like everybody to calculate that, please.